Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Nur M binti Muhammad Amin and my metric number is I191-03637. I would like to present about Chapter 7, Telecommunications, the Internet and Wireless Technology. The subtopic is 7.4. What are the principal technologies and standards for wireless networking, communication and Internet access? My first slide was cellular systems. Welcome to the wireless revolution. Cell phones, smartphones, tablets, and wireless-enabled personal computers have morphed into portable media and computing platforms that let you perform many of the computing tasks you used to do at your desk, and a whole lot more. In 2015, more than 1.5 billion cell phones were sold worldwide. In the United States, there are 351 million cell phone subscriptions and 190 million people have smartphones. 3G networks, with transmission speeds ranging from 144 kbps for mobile users in say a car to more than 2 mbps for stationary users, offer fast transmission speed for email browsing, the web, and online shopping, but are too slow for videos. Next, 4G networks. It have much higher speeds, 100 megabytes or second download and 50 megabytes upload speed, with more than enough capacity for watching high-definition video on your smartphone. Long-term evolution LTE and mobile worldwide. Interoperability for microwave access WiMAX. As see the following section are the current 4G standards. Next, we go to wireless computer networks and internet access. First, Bluetooth. Bluetooth is the popular name for the 802.15 wireless networking standard, which is useful for creating small personal area networks (PANs). It cleans up to 8 devices within a 10-meter area using low-power radio-based communication and can transmit up to 722 kbps in the 2.4 GHz band. Wireless phones, pagers, computers, printers, and computing devices using Bluetooth communicate with each other and even operate each other without direct user intervention. For example, a person could direct a notebook computer to send a document file wirelessly to a printer. Bluetooth connects wireless keyboards and mice to PCs or cell phones to earpiece without wires. Bluetooth has low power requirements, making it appropriate for battery-powered handheld computers or cell phones. Second, Wi-Fi and wireless internet access. The 802.11 set of standards for wireless LANs and wireless internet access is also known as Wi-Fi. The first of the standards to be widely adopted was 802.11b, which can transmit up to 11 Mbps in the unlicensed 2.4 GHz band and has an effective distance of 30 to 50 meters. The 802.11g standard can transmit up to 54 Mbps in the 2.4 GHz range. 802.11 and is capable of transmitting over 100 Mbps. Today's PCs and netbooks have built-in support for Wi-Fi, as do the iPhone, iPad, and other smartphones. In most Wi-Fi communication, wireless devices communicate with a wireless LAN using access points. An access point is a box consisting of a radio receiver or transmitter and antennas that leads to a wire network, router, or hub. Hotspots are locations with one or more access points providing wireless internet access and are often in public places. Some hotspots are free or do not require any additional software to use. Others may require activation and the establishment of a user account by providing a credit card number over the web. Businesses of all sizes are using Wi-Fi networks to provide low-cost wireless LANs and internet access. Wi-Fi hotspots can be found in hotels, airport lounge, libraries, cafes, and college campus to provide mobile access to the internet. Dartmouth College is one of many campuses where students now use Wi-Fi for for research, coursework, and entertainment. Third, WiMAX. A surprisingly large number of areas in the United States and throughout the world do not have access to Wi-Fi or fixed broadband connectivity. The range of Wi-Fi systems is no more than 300 feet from the base station, making it difficult for rural groups that don't have cable or DSL service to find wireless access to the internet. The Institute of Electrical and Electronics Engineers IEEE developed a new family of standards known as WiMAX to deal with this problem. WiMAX, which stands for Worldwide Interoperability for Microwave Access, is the popular term for IEEE standard 802.16. It has a wireless access range up to 31 miles and transmission speed up to 75 Mbps. Next, we go to RFID and wireless sensor networks. Radio frequency identification as RFID provide a powerful technology for tracking the movement of goods throughout the supply chain. RFID systems use tiny tags with embedded microchips containing data about an item and its location to transmit radio signals over a short distance to RFID readers. The RFID readers then pass the data over a network to a computer for processing. Unlike barcodes, RFID tags do not need line of sight contact to be read. The RFID tag is electronically programmed with information that can uniquely identify an item, plus other information about the item such as its location, where and when it was made, or its status during production. The reader emits radio wave in range anywhere from 1 inch to 100 feet. When an RFID tag comes within the range of the reader, the tag is activated and starts sending data. The reader captures this data, decodes them, and sends them back over a wired or wireless network to a host computer for further processing. Both RFID tags and antennas come in a variety of shapes and sizes. In inventory control and supply chain management, RFID systems capture and manage more detailed information about items in warehouses or in production than barcoding systems. If a large number of items are shipped together, RFID systems track each pallet, lot, or even unique item in the shipment. This technology may help companies such as Walmart improve receiving and storage operations by improving their ability to see exactly what stock is stored in warehouses or on retail store shelf. Macy's, described in the chapter opening case, uses RFID technology to track individual items for sale on store shelf. Near Field Communication (NFC), a short-range wireless connectivity standard that uses electromagnetic radio fields to enable two compatible devices to exchange data when brought within a few centimeters of each other. A smartphone or other NFC-compatible device sends out radio frequency signals that interact with an NFC tag found in compatible card readers or smart posters. The signals create a current that flows through the NFC tag, allowing the device and the tag to communicate with one another. In most cases, the tag is passive and only sends out information while the other device is active and can both send and receive information. NFC is used in wireless payment services to retrieve information and even to exchange videos or information with friends on the go. You could share a website link by passing your phone over a friend's phone while waving the phone in front of a poster or display containing an NFC tag could show information about what you are viewing at a museum or exhibit. Wireless sensor networks, networks of interconnected wireless devices that are embedded in the physical environment to provide measurements of many points over large spaces. These devices help built-in processing, storage, and radio frequency sensors and antennas. They are linked into an interconnected network that routes the data they capture to a computer for analysis. These networks range from hundreds to thousands of nodes. Because wireless sensor devices are placed in the field for years at a time without any maintenance or human intervention, they must have very low power requirements and batteries capable of lasting for years. Output from RFID systems and wireless networks is fueling the Internet of Things (IoT). Introduced earlier in this chapter, in which machines such as jet engines, power plant turbines, or agricultural sensors constantly gather data and send the data over the Internet for analysis. The picture shows a wireless sensor network. The small circle represent lower level nodes and the larger circles represent high-end nodes. Lower level nodes forward data to each other or to higher level nodes, which transmit data more rapidly and speed up network performance. Okay, now that's all from me. Thank you for watching my video. Bye and Assalamualaikum warahmatullahi wabarakatuh.